In this video, we're going to go over the basics of preparing a 3D model for 3D printing in Blender. You'll want to go to your preferences and enable the built-in add-on 3D Print Toolbox. So just search and check that. And you'll find it under the sidebar by pressing N and going to the 3D Print tab. First, we have some settings for the size. We got volume and bounds. I'll choose bounds and choose 2 inches because I want it to be a fairly small print. If you end up zooming in too close and you have it start clipping, you can go to View and change your clip start to make it much smaller. And now I can zoom in and it won't clip. Next, we got some tools to analyze our model. I can find the size of the model using the volume and area buttons. I can also have various checks, such as I can check if the model is solid. It shows that I have 42 non-manifold edges, in this case around the eyes, where there's holes in the mesh. We have a button here to make it manifold. It'll try to automatically fix it, which now has no more holes. However, it might not be as clean as you want it. So I'll undo this and then I will try to do it manually later. This, along with the other potential problems here, aren't guaranteed to create a bad final print, depending on how the slicer program interprets the model. However, fixing these issues will improve your odds of having a good result. Another option is to check for intersections, and if I select this, you'll see that I have several faces around the eyes where there's intersections because of it having 2 separate meshes here. I'll fix this problem later as I'm fixing the holes. Next, we can check for distorted faces, which are faces with more sides than a triangle, but aren't completely flat. If I press the Clean Up Distorted button, it'll convert them to triangles, so it knows which triangles to use when you print. Each of these buttons has a setting on its side, which is its threshold for what it considers bad. Next, I'll check for thickness. I have several thin areas, such as the ears, so I'm going to go ahead and fix the ears just by selecting them and pulling them out a little bit. I'm not worried about the other areas right now. We can check for sharp edges, which would produce thin results, such as if I created some edge loops here and pulled this out. The problem is this edge is too sharp and would become too thin. So if I check again, you'll see under both thickness and edge sharp that it's too thin. Next, we can check for overhang, which will be areas that are going to need support when printed, or it could be maybe gotten around using various techniques. Here I'm trying to clean up my messy eye area by using the knife tool to add some edges, deleting that stuff behind it, and then trying to use snapping tools to connect here, and then I will eventually go ahead and merge by distance to remove all those. Next, I'm just going to symmetrize. Next, you may want to print your model in multiple pieces. The obvious reason for that might be that you're creating something that's too big for your printer to do in one print. Another reason is that you can get rid of overhang and then not have to use so much support with your print. One possible method for this is to create a box and then just use booleans. Using the bool tool add-on, you can skip the step of manually setting up the modifier yourself. This is just an add-on you need to enable in the preferences. I'll use intersect, and you can see that the top half was cut off. But first, I'll need to create duplicates. Now that I got a duplicate of the box and the monkey, I can just intersect it on one duplicate and then move the other box up and intersect it on the other duplicate. You could potentially skip the moving step by just using difference on one and intersect on the other. Now we have two halves. You might want to use like a Lego intersecting technique, but we won't do that in this video. You may need to do a little bit of cleanup of your booleans. I can use the export tool by setting the location, choosing apply scale, and hitting export on each of these. The STL format is the most popular for slicers. For my slicer, I'm going to use Ultimaker Cura, which is free. A slicer is just a program that you import your 3D model into, and then it will generate instructions for your 3D printer to print it. When you start it up the first time, you should get a message to set your printer, but I'll show you up here that you can set it there. And next to that, you can select your material type, which I'm using PLA plastic. Next up, I'll go and open up my 3D models. We have some transform tools on the side. I'll use the rotate tool to rotate this to be flat. Actually, I'll delete this right now since I'm just going to print one at a time. You have the option of printing two at a time, but you have to make sure they don't get in the way. Under the preview tab, you can see the preview of what path the printer will take to print it. You got a slider on the side, which you can use to see the different layers. In the bottom right, you'll see the estimated print time. And in the top right, you can choose the profile, which are some presets for the other settings here. An example is fine, which will have presets for a higher resolution. Or coarse, which will be really low resolution. I think the middle draft option is going to be good here, which will give it more of a 3D printed look where the layers will be big enough to be very noticeable. We got various settings here, like how many lines should make up the outer walls, the thickness of the top and the bottom. There's also the infill setting, which I accidentally skipped when recording. This is how many lines make up the grid inside. Raising it makes it stronger, while lowering it will reduce your printing time and your material usage. For display-only models, you can get away with surprisingly little. There's also the material temperature settings, which you can usually leave as default. Build plate adhesion here will help you to increase the odds of your first layer sticking. None looks like this, and the setting I usually use is brim, which leaves a little bit of an edge at the bottom that you have to peel off, but increases the stickiness. There's some other settings that you might have to change in troubleshooting, but probably shouldn't if your printer is supported by default. And then I can just hit save to removable drive, which will save it to my SD card. You can also print straight to the 3D printer with a cable or a network from your computer if your printer supports that. However, I'm just going to use the SD card because it's simpler and I don't have to worry about my computer crashing in the middle of it or something, which will cause the print to fail. And then I'll just prepare the other model as well and save it to my SD card. And now we begin the print. Now, usually if you have a clean model and it looked good in your slicer's preview, your print should hopefully be successful, but a failed print comes down to usually one of a few things. One is that you had a bad first layer or two where it didn't stick down properly, and then it ended up maybe sticking to the nozzle, getting moved around, and various issues that build up over time to cause a mess of a final print. This could be due to things like having the wrong calibration settings on your printer, so it's not printing at the right height, or because of wrong printing temperatures, or a bad print surface, which should be clean and perfectly flat. There's other tricks to helping improve your stick, such as using the brim to make the first layer wider, or using sticky things on the print surface such as tape. Other possible problems are not having your model being properly supported or having flaws in your model's design. If you found this video helpful and want more videos on 3D in Blender, then like, subscribe, hit the notification bell, and leave me a comment down below. Thank you.